Good afternoon, dear colleagues. Today we are going to talk about such a widespread and gaining popularity method of data analysis as graph analytics. Let's look at illustrative examples and understand how you can use the advantages provided by this method of analysis in addition to the methods you already use. The very concept of graphs came to us from discrete mathematics. A graph is a mathematical object that depicts relationships between entities. I will emphasize the word relationship here. A graph consists of vertices of entities and edges, relationships. Graphs can be used to represent different situations. Graph analysis is a powerful tool. It is a set of methods aimed at studying the relationships between entities. With the help of these methods, the structure of the graph is explored and non-obvious dependencies are identified. In other words, graph analytics is a set of techniques aimed at exploring complex dependencies between entities, which allows us to find relationships and predict likely relationships in complex interconnected structures. Graph analytics is used in many analyses and their subsequent uses in fairly mundane situations. Here are a few examples of uses. For example, graph analytics is used in logistics, specifically in navigators, to determine the shortest route between travel points. Also, graphs help transportation companies to determine the optimal location of distribution centers and warehouses. In telecommunications, cellular operators use graphs to determine the number and location of cell towers to ensure maximum coverage. For the banking sector, graph analytics allows you to analyze your customers. For example, check if they meet the criteria for a loan. Graphs are also used for anti-fraud to identify fraudsters and affiliates. The marketing sphere in general uses this type of analysis for its tasks as often as possible. For example, to identify the most influential people in the social network, which is very important for marketers and advertisers. In order to direct their attention to these people, graphs are useful for creating recommendation systems based on user preferences, browsing history, and product similarities. HR departments apply graph analytics to their tasks, such as identifying social groups or expert leaders that colleagues look to for advice. This allows for more effective management of the organization's HR policy, in particular, the assessment of hidden competencies and potential growth areas. Fraud management uses this methodology when it is necessary to find indirect links between legal entities or individuals where these links should not be, in accordance with the norms accepted in the organization. Graph analytics provides powerful and flexible tools for analyzing data, especially in situations where relationships between entities need to be considered. There are many tools and query languages that simplify working with graphs. We will talk about one such tool in detail today. We will talk about a specialized extension for Qlik Sense BI product. In general, graph analysis is an ideal addition to BI because, firstly, BI itself is a tool that is originally designed for working with data arrays and already contains sets of tools for analyzing them in addition to the data itself. Secondly, BI is a tool for users, in particular analysts. They are the main consumers of graph analytics. Therefore, embedding graph analytics into BI is an obvious and logical solution. Let's take a look at examples of how ready-made graph models embedded in Qlik Sense look like.